Greetings, fellow teachers. My name is Tom Love. Welcome back to Basic Mathematics Using the Garden Approach. This session will be on problem solving. Now, in this session, we will have a lot of problem solving situations in geometry, as well as a lot of problem solving situations in the real world. We'll have people involved, we'll have items involved, we'll have situations involved, but we'll have to set them up. Our main job is to take these word sentences, change them into symbolic representations, and then find the solution, and most importantly, check our solutions. All right, let's get started with problem solving. All right, now remember that problems are word sentences that we need to change into a visual representation. And if a problem has two parts, it would be nice to make a little board that has two parts. Or if it has three parts, we've got a little board that has three. And of course, it would be nice to put some variables on top of the boards to organize our data. Now, a valuable piece of information, again, with these story problems is that we can, most of the time, without any trouble at all, change the word than to and it'll really help us with it. In this case, we can see that we have 3 feet less than twice, and we could say 3 feet less and twice, and you see here it is twice, and it's 3 feet less. Where in this one we have 5 feet more than half the other. We can say we have 5 feet more and half the other. So do you see here we have half, and of course we have 5 feet more and half. All right, two complementary angles are such that one is 10 more than 1/3 the other. So we replace this with the word and. One of the angles is 1/3 and it's 10 more. So do you see this angle is 1/3 of that one and it's 10 more. So we've got it set up. All right, now we combine all those and we have 4x's plus 10 equal 90 degrees. Complementary angles. Boy, look at all the geometry we have to remember. All right, now what can I add to 10 to get 90? Well, that would be 80. Now, do you see we're using reasoning here to figure this out? And that, of course, means that x is 20. So that means I have 20 plus 10 here, and then I have 20 plus 20 plus 20. So that gives me 30 for one and 60 for the other and 90 degrees. So it all checks. In the next problem, we're talking about two supplementary angles are such that one is 30 less than twice the other. Well, it's 30 and it's twice the other. Okay, so we've got it twice the other one and it's 30 less than the other one. So you see how the setup is here. All right, we can check the way we set it up. As soon as you set it up, you need to go back to the words and make sure you have set it up right. All right, now they're supplementary, so it's 180. Now we combine it all into a symbolic statement, and we have 3x's minus 30 equals 180. What can I subtract 30 from and get 180? That would be 210. That means that x is 70. So that means I have 70 plus 70 minus 30. So that's 140 minus 30 be 110. And then, of course, the x is 70. 110 and 70 is 180, and it checks. Next one. If the base angles of an isosceles triangle, now remember an isosceles triangle is such that basically it looks like that. The base angles are equal and the sides are equal. All right, now if the base angles of an isosceles triangle are 20 less than half the third side, okay, which in this case is basically the base, all right. So you see here, this is a side and this is a side, and you see this side is half. It's 20 less and half, and this one is 20 less and half. So everything agrees with the words in our symbolic setup. Now we'll put it into a symbolic equation, and we have 4x's minus 40. See, combining all the terms in our setup. Now, what can I subtract 40 from and get 180? That would be 220. And see, that goes back to our simple solving of algebraic equations just using reasoning. All right, and that means x is 55. So that means I have 55 here minus 20. Then I have 55 plus 55, and I have 55 minus 20. So I've got 35 for each one of the base angles and 110 for the the other angle. And then, of course, you see the 35 and the 110 add up to be Oh, no, it's 35 twice, isn't it? So it'd be 70 plus the 110 is 180. Boy, that wasn't checking for me. All right. Good thing we do our check, huh? All right, now, here we've got a scalene triangle. Now, remember, a scalene triangle is such that all the sides are different. All right, a scalene triangle and all the angles will be different, but yet they still equal 180. One angle of a scalene triangle is half another. A third angle is 20 less than the first one. All right, that's not too bad. One angle is half another, where the third angle is 20 less than the first one. So see, you had to designate which is the first one there. Okay, so that's not too bad. And they're all set up and they agree with the word. All right, we combine them here, and 180 is the sum of all the angles. So we've got 4x minus 20 equals 180. What can I subtract 20 from and get 180? That would be 200. So that means x is 50. All right, so that means I have 50 here, 50 plus 50 here, and then I have 50 minus 20 here. So I end up with 50, 130, and of course that ends up being 180 and everything checks. All right, now let's talk about perimeter. The perimeter of an isosceles triangle. Again, the old isosceles triangle here, where basically the sides are the same and the base is different. Excuse me. The perimeter is 48 feet. The base is twice the sides. Well, that shouldn't be any problem. Look at this. Here we go. Now, we know the perimeter is 48, so we got that up, and there's 3 parts to it. Now, the base, all right, is twice either of the heights or the sides, and those are the sides. So we just combine all those. We have 4x equals 48, so x equals 12. So that means I have 12 here, 12 plus 12 here, and 12 here. So guess what? It checks, and we get 48. Side 1 is 12, the base is 24, and side 2 is 12. Now we got the perimeter of a scalene triangle. All the sides are different on a scalene. It really helps when you can understand and visualize what this is when you're working through these problems. And all that came about by learning all the basic types of figures and names in geometry. Now, the perimeter of a scalene triangle is 41 feet. All right. Now we've got this set up here where we know the perimeter is 41 feet and there's 3 sides. All right. One side is half another. Okay, we've done that before. That's no big deal. And a third side is 5 more than the first. Well, here's the first, so it's 5 more. That's no big deal. So now we set it up. We have 4x plus 5 equals 41. Now, what can I add 5 to and get 41? That would be 36. Let's check. 5, 36, 41. Great. Okay, that means x is 9. So I've got a 9 here, a 9 plus 9 here, and a 9 plus 5 here. So that gives me 9, 18, and 14, and that all adds up to be 41. How about that? All right, now the next one, the perimeter of a rectangle. Now here I underlined it for a reason. Students tend to get those words mixed up. We need to emphasize that there is a difference between a rectangle and a triangle. And as soon as they see those words, they may get confused. Angle, angle. You see it? It's triangle and rectangle. Dumb as that may seem, it does happen. And I'm sure some of you run across that. So we need to stress that when we did the part in geometry where we recognized the names and the figures. The perimeter of a rectangle is 42. Well, this problem has 4 parts, doesn't it? Okay, the length is twice the width. All right, here's the length. It's twice the width. Here's the length. It's twice the width. No big deal, right? So then I combine all those and I get 6 x's. What can I multiply times 6 and get 42? That's 7. So that means I have 7 plus 7, 7, 7 plus 7, 7, 14 for the lengths, 7 for the widths. It all adds up to be 42. Nice and easy. It is rather simple that we're taking all this previous knowledge of geometry and our knowledge of story problems and changing word sentences into images, and it just makes the problem very easy. You're going to be surprised your students do rather well with this. Now we'll do something similar, but different. All right, perimeter of a rectangle, we don't want to confuse that with a triangle now, is 26, and we've got that down here. The width is 3 less than the length. All right, so here's the width. It's 3 less than the length, and this one's 3 less than the length. Now, we don't want to get real technical here and only do 2 of them. We want to do 4 of them. That's always it. I've seen some students that say, well, I only need to do 2, and I'll go ahead and figure it out and double it. Well, they end up in the check situation, and they check it, and they've only checked 2. So make sure if there's 4 parts of the problem that we draw an image that has 4 parts. All right, now here we've got 4x minus 6, combining all the terms in our image. Now, what can I subtract 6 from and get 26? And that'd be 32. All right, what can I subtract 6 from and get 26? That would be 32. So that means x is 8. That means I have 8 minus 3 here, 8 here, 8 minus 3 here, and 8 here. All right, and then 8 minus 3 is 5, and the lengths are 5. And here, add it all up, gives me the 26. Works out pretty good, doesn't it? All right, now, again, I want to stress that word problems are word sentences that need a visual representation. The boards are a good way to go. Putting the symbols on top and putting your checks underneath are another way to help you really visualize these problems. Now we're going to talk about situations about people and things and see how this works out. All right, many problems in word or real life situations have formulas. Now, there should be so many of these that we understand most of the formulas, and in most cases we have studied the formulas, and we've certainly looked at distance equals rate times time. Hopefully we studied something of interest equals principal times rate times time, and gross pay should not be anything bad, because basically if we make like $2 an hour and we work for 10 hours, we make $20. That's almost like distance equals rate times time. The tricky ones here that we're going to deal with is percent of increase and percent of decrease, and we're actually using an absolute value here, which is a very good idea. All right, so let's just jump into here and see what we can do with these. All right, now busboy makes $18 in 3 hours. All right, now it's nice that in my problems I kind of give you the situation. What is the rate of pay? And then a second question here I underline, how much is made in 8 hours? Okay, now here's the situation. The gross pay is 18. We work for 3 hours. And what's that rate? Well, what can I multiply times 3 and get 18, and that would be 6, isn't it? All right, so that means I'm making a rate of $6 an hour. It checks down here. Now also, at same rate, how much money am I going to make in 8 hours? That'd be $48. You need to watch out because you don't want to jump to and start working the problem and see that there's 2 parts to it. All right, the next one. A waitress makes $24 at $6 an hour. And again, you're lucky I'm giving the formula, but it's simple. All right. Now we lay it all out here. $24 at $6 an hour. How much time is being involved here? What can I multiply times 6 and get 24? That turns out to be 4. So we check it down here, and 24 times 6 times 4 works all out. But how much time if we make $120? All right, we're making $120 here at the same rate, so we find out it takes 20 hours times the 6 to give me the $120. So the 20 hours would be the extra part of the problems here. Now the first set of problems all dealt with geometry. We did all types of angles with triangles, all types of perimeter with triangles and rectangles. We did a lot of real life situations that had to do with formulas, and we handled it without any trouble at all. We took the word sentences, changed them into a visual image, came up with an equation that basically we can solve with reasoning. Everything is coming together. This is something that is very much worked on and gives students success and confidence that they will go on in mathematics, do more in mathematics, and do well on standardized and proficiency tests. Well, that's the end of the session. Have a good day, and hopefully see you in the next session.